Dave Doyle, geodesist, joined the National Geodetic Survey in 1972 and held the position of Chief Geodetic Surveyor at his retirement in January of 2013. He was responsible for the development, technical design, and management of plans and programs that enhance the United States National Spatial Reference System. Mr. Doyle began his career as a geodetic surveyor in the Army in 1967. And from 1970 to 1972, he worked for a private surveying company near Washington, D.C., where he was responsible for completing boundary, topographic, and engineering surveys while he pursued his undergraduate studies in geodesy and mathematics from George Washington University. Mr. Doyle is a past president of American Association of Geodetic Surveyors and a fellow member of the American Congress of Surveying and Mapping, a charter member of the Geodetic and Land Information Society, and served as the U.S. delegation to the International Federation of Surveyors. Mr. Doyle is also an active member in the District of Columbia, Maryland, and Virginia Surveyors Professional Associations, and was awarded the 2008 Surveyor of the Year by the Maryland Society of Professional Surveyors. Thank you, Mr. Doyle. It should be another awesome topic for tonight, and we appreciate you joining us.
Oh, my pleasure. Truly my pleasure.
Thank you, sir.
We ready to rock?
You are ready to go.
Okay, cool. All right. So Trent had contacted me some time back about doing something for entering Mondays. I think this is a great idea. Oh, I like this. And so I popped out a few ideas, and I'm glad he picked this one. GPS-derived orthometric heights. In my professional development, as I was growing up in the world of geodesy and geodetic surveying, especially in those days, the late 60s, 70s, I became part of a process of how to find the right way for this. Having a little bit of geodetic arrogance in the community, right? Because I was what we called a horizontal guy. I was actually an astro guy. Most of my time in the service, I was out performing astronomic observations. And I mean, you talk about an awesome way to do your service time. This is terrific. I'm in Germany for 2.5 years, tracking stars, drinking beer, and eating schnitzel. I mean, life got no better. And then it came to NGS, and there was in the horizontal network branch. Well, on the horizontal side, first of all, it's two-dimensional. It's very difficult. And we had great toys. We had towers. Huh? We had to build towers, sometimes well over 100 feet tall, to make our observations. And we had cool toys. I mean, we had EDM back in those days that, well, the longest line I ever observed with an EDM was about 65 miles, but we had several down around Fort Davis, Texas. We did 91, 92 miles. This is pretty awesome stuff. So at that time, and in the context of where I worked at NGS, the level of arrogance was, you're on the horizontal side, that's the most important side. It took me a while to kind of get it into my head that in reality, nah, not even close. It's vertical that is the most important. And I can remember thinking back in the day, how can this be? I mean, how hard is vertical? How hard is it to run levels? You can teach a squirrel to run levels in a couple of hours, right? It's just not that difficult. The reality is that in the context of not just the National Spatial Reference System that NGS provides, but in the full context of all things that surveyors do, the vertical is 3 times more important than the horizontal. Within the context of the horizontal, yes, a boundary is obviously very important, but in a geodetic context, that is where that parcel is physically on the surface of the earth, by and large, not too many people care. As long as it's within the boundary and you're doing whatever you got to do. But everybody wants to know where water and other fluids are going to go. This is the big deal. And in reality, at least from a computational standpoint, leveling vertical is really the hardest part. So we're all familiar with that and we've all done it. But what's happened, the transition from leveling to GNSS-derived heights, if you go back to the earliest developments in GPS, and obviously at NGS, we were exceedingly fortunate to be a part of the very first GPS. I worked on the very first GPS, practical GPS survey, which was Summit County, Ohio, back in 83. And in those days, right up till the mid-90s, you did not say the word vertical and GPS in the same sentence. It was just like, no, bad dog, don't do that, right? We're not going to be able to get good vertical from GPS. Well, by about the mid-90s, things have changed a lot. And obviously today, most people don't even remember those. I mean, if you've been doing GPS, GNSS, and you go back to the 80s and early 90s, and you would listen to somebody come in into a state conference and talk about how it's done and how it's processed, you might remember that back then they would say, well, no, you're not going to really get good vertical. And that's not the case anymore. That being said, it's good, but I find it being overused a lot. And regrettably, all too regrettably, in our community, the community of surveyors, I find far too many that I've talked to, I've given presentations at, I've looked at materials they've provided, in which I see that there's a whole lot of folk out there that just don't know how all the little pieces fit together. So that's kind of what I want to talk about tonight, GPS-derived orthometric, GNSS-derived orthometric heights. And anybody got a question at any point in time, throw it out there, do it. If you got something that comes up later, you got my phone number down here, you got my email. Don't ever hesitate to send me a note, give me a call, whatever. I'll be happy to deal with you. All right, so the first thing we have to do, and I know I'm preaching to the choir on this, but I want to make a couple points. Obviously, the global positioning system, GPS, has changed the dynamic of everything we do. And not just us in the surveying community, but so many other disciplines are using GPS for limitless numbers of applications. And I want to highlight a couple of things. First of all, the system's been up and operational for quite a while now, so that, that's well known. But I want to point out some of the ones here on the bottom, right? So like December 23rd of 2018, the US launched the first satellite of the Block 3 constellations. We now have 4 of them, right? 4 Block 3s. Game changer. Block 3 is a game changer, right? These are advanced architecture in GNSS technologies. They will give us ultimately, when the system becomes operational, our third civil frequency, L5. Right now as civilians, we get L1 and L2. Everybody's got a box that'll get L1 and L2. You probably have boxes that'll get L5, it's just not turned on yet. GPS-3 functionality, full functionality. This comes from the Air Force. Mid to late 2023. So we're creeping up on it real fast. This is going to have a lot of implications in so many things. And in part, this is sort of the driving force behind why NGS wants to change both our horizontal and vertical datums. And I'll talk about that at the end of the presentation. The point at the bottom. Now, this is my estimation, right? 2024? Yeah, maybe. I don't know. It might be next year. It might be 2022. It might be 2027. I don't know. But here's what we will be looking at. No ground control, right? No monumentation, no cores, no nothing. Straight from the satellites. We can be, and just GPS alone, not including the rest of the GNSS constellation. We could easily be looking at roughly about 1 foot, 2-dimensionally, 95% of the time in a cell phone. That's where we're headed. So this is going to be the next couple of years are going to be incredibly challenging and advantageous for so much. I mean, our positioning capabilities are going to be beyond anything we've even experienced up till now. And in my mind, what I would like to see is the professional surveying community take real leadership in this, because we're going to have millions of people out there punching buttons and getting numbers and nobody understanding what they mean. And we already see it in our community. You know, if GPS was the great panacea that many thought it would be, you'd never have occasion where two surveyors are sharing data and the information misses by, let's say, state plane coordinates missed by 15 feet or heights missed by 6 feet or something. And we've all seen this stuff. We've all seen it. So it's important for us in the professional community to really understand what's going to be going on here, because I think it's a tremendous opportunity for professional surveyors to be real leaders in this. Don't let it pass us by, much like we did with GIS. So just a point out there. Okay, GNSS, well, we all know where this is. So it's the US. Gosh, we were the first to go up, and the Russians, go figure, the Russian GLONASS is similar in many ways, of course, to GPS. The European Union, Galileo, and the Chinese Beidou. All of them are totally functionally operational right now, and they all have interoperability capability. The only thing we lack in the United States right now is that NGS, the NGS processing software for all GNSS applications is currently GPS only. So if you're using a tool like Opus, you're downloading the data from the cores, all you're getting is the GPS side of it. Right? So if you're multi-constellational, NGS isn't yet. Little birdies tell me that next couple of months, there's going to be an announcement for some new software that hopefully will be multi-constellational. So I know NGS is working very, very hard on that point. So if we're going to look at height, if we're going to look at GNSS-derived orthometric heights, we're going to know what all the heights are. And I can't tell you how many times I've stood up in front of a group of engineers or GIS people and say, you know, there's many different types of heights, and you get this, you know, deer in the headlights look, because it's like, isn't a height a height? You know, well, there's obviously any number of heights. Now, the ones we want, the ones that are most important to us, because it's how we understand where water and other fluids are going to go, are what we commonly refer to as orthometric heights. And in the conterminous United States, that's represented by the North American vertical datum of 88. Now, those heights derive exclusively from leveling, NAVD 88. And I can't tell you how many times I've heard somebody say that NAVD 88 was derived through GPS. It is not. It has nothing to do, GPS has nothing to do with the development of NAVD 88. NAVD 88 is totally, completely defined by geodetic leveling. That was all conducted by the Coast and Geodetic Survey, the National Geodetic Survey, and a few other agencies and some private sector folks that date back to the first transcontinental leveling in 1876. And so with leveling, we can easily achieve, if we're mindful of techniques and processes, we can easily achieve sub-millimeter height differences over sometimes relatively long distances. So leveling is without a doubt the best way to determine height differences. That's key. To develop our orthometric heights from GNSS, we have to have the other two, our ellipsoid heights and the geoid heights. Now, the ellipsoid height is the height we get from GNSS, and it is the height above the reference surface, so the reference ellipse that is used for NAD 83. So that's a different datum. It's what we formerly used to refer to as a horizontal datum, because it was two-dimensional, latitude and longitude, northern and eastern state plane or UTM coordinates. But literally ever since the early 80s, NAD 83 has now been what we refer to as a geometric datum, because it's got a third dimension. It has a height, but it's the ellipsoid height. And the ellipsoid height has nothing to do with the Earth's gravity field. So water doesn't necessarily flow downhill in ellipsoid heights. Right? So those heights, depending upon how we make our observations, at the 95% confidence level, see my estimates there at the bottom, you can achieve roughly 2 to 4 centimeters at the 95% confidence level, if you're mindful of how you're doing things. So right away, you're way more uncertainty than you have with leveling. And then to achieve what appears to be an orthometric height, we now must have the geoid height, or the geoid separation. And that's the value of the distance between the ellipse that defines the datum, the NAD83 datum, and that surface that's called the geoid. If you don't know what the geoid is, I'm going to show you that in just a second. Today, with what we have right now, most current Geoid 18, we can model that across the country relatively in the several centimeter level. And I gotta tell you, we are terrific at doing this. I've had great fortune to work with multitudes of countries around the world that have been developing GNSS technologies. And by and large, they almost always have to throw away that height component because they have no good geoid models. I've done a lot of work in the Caribbean, South America, Africa, and parts of Asia with various countries. And developing a geoid model is the big deal. And what we have in the United States right now with the work that the Geoid team does at NGS is nothing short of incredible. It's just something we couldn't have even dreamed of. We never had them before. When I first joined NGS and we were still working on the NAD27, there were no geoid models in NAD27. There were no ellipsoid heights in NAD27. There were no ellipsoid heights when we finished NAD83 in the summer of 1986. When we pushed it out the door, if anybody has some of that old paperwork kind of laying around the office, you might go back and look up some old stations and coordinates and state plane, whatever. You'll never find an ellipsoid height back in. Those did not come along until we started our first GPS surveys. And I remember when we were processing Summit County, Ohio, this back in 83, we finished the processing and now we have this new value. We have this ellipsoid height. And quite literally, those of us on the senior technical staff at NGS, we looked at this thing and we go, well, what do we do with it? We have no products and services to deal with this. And I mean, we brought everybody's brain together and like, we don't know. And it was only good to maybe, about a meter or so. Everybody was like, well, yeah, we got it. We should put it out, but we don't know what we're going to do with it. We have come a long way, right? And we're going to get so much better. This is so cool, all right? So just to highlight, and let's make sure we're all on the same page. Vertical datums, 2 types, primarily. Well, in the surveying world, 3 types, because almost every surveyor's gone out somewhere, whacked a railroad spike and a utility pole and looked at it, went, yeah, it looks like 2,000 feet to me, and went off and ran levels. We're not talking about that. In national height systems, there are 2 types. Because we are a coastal country, obviously, we have tidal datums. Tidal datums, and here you see part of the realm of those: mean low water, mean high water, mean sea level. Mean sea level is an official tidal datum. And I put this in here because I wish I could tell you, I wish I had jotted down over the years, I wish I had jotted down in some little notebook or in a file somewhere, how many times I've gone to a state conference and I would wander around the plat competition. And I would see some surveyors and listed heights on there, and they would refer to the heights as mean sea level. And they'd be in, I don't know, Kansas. There's no mean sea level in Kansas. Hasn't been mean sea level in Kansas in 40 million years, right? So mean sea level is a very specific tidal datum and only exists close to the shoreline within a few miles, depending upon where you are and how it works. So I put that in there just to resonate on that, to make sure we're comfortable understanding that, yep, there are tidal datums, there are heights that are related to tidal datums, and they are purely for mapping and engineering applications in the tidal zone. But to make things fit over a large area, because, quote, mean sea level, local mean sea level, is not a level surface everywhere. That is mean sea level in Sandy Hook, New Jersey, not too terribly far from me, is not the same level surface as mean sea level in San Francisco. There's roughly about a meter between east and west coast, approximately. Varies depending upon where you are. So to deal with that, we developed a geodetic datum. The idea behind the geodetic datum is now it's going to be connected to sea level. We're going to start at a tide gauge somewhere, or several tide gauges if we look back at older datums. And now our heights are going to be consistent. So as we're building stuff from Maine to California, those heights are going to be consistent all the way along the way. If you were trying to do this in tidal datums, you would never be able to do it. You can't survey from lower New Jersey at Cape May to Sandy Hook, New Jersey in the northern part and be on the same height system if you're in mean sea level. So it's kind of important to get that, make sure we're all clear on that. So these accurate heights, and heights, as I've mentioned already, I understand these are truly the most important part in almost any survey that's conducted. The best way to do it, obviously, leveling. Well, you see my points here. It's expensive. We all know that. Time consuming, and you got to have people that really know what they're doing. You got to have rodmen that really know what they're doing. Boy, that was a big one for me to understand. The most important person on a level crew was the rodman. That was something I learned very early on. But a good level crew, even if you're really fantastic, an NGS level crew, some of the best in the world. Maybe the Dutch do it a little bit faster. The Finns do it pretty well too. You might be able to do geodetic leveling 10 miles a day, double run, maybe, Well, that's not really very far when you consider how big a country it is. So we have it's tough to do. Now GNSS comes along and we have vertical capability. And obviously, right away, it's cheaper, faster, and you don't need people who are trained the same way. So in many applications, people want to be able to use the full capacity of GPS, GNSS observations. Regrettably, I've seen far too often where they don't fully comprehend these issues of accuracy. Give me an example. This goes back to, must be 2009, I suspect, when we had the big economic downturn. A surveyor friend of mine that lives up near Baltimore had called me, and he commented, he said he had a contract with NASA. They wanted some first order control, horizontal and vertical control at the NASA facility in Greenbelt, Maryland. They have a lot of very long baseline interferometry observations there, satellite laser ranging. They do a lot of research there. So NASA, and then NASA doesn't have their own surveyors. So they contracted his company to come in and put in some first order control. Well, I'm real happy for this buddy of mine. Hey, you're working. This is great. And he asked me. He says, will you point me to the documentation? What do I need to know to provide first order horizontal and vertical to these folks at NASA? Oh, sure, no problem. So I said, okay, you're going to go do your GPS work. Blah 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 blah. Here's what you're going to do. And I pointed him to several documents from the federal government, from NGS. And I said, now you follow these, you're going to easily get first order horizontal. I said, now for the leveling. And I'd barely gotten that out of my mouth when he said, no. He said, I want to do it all with GPS. I said, you can't. You can't. Leveling, heights, first order heights can only be done by leveling. And I knew right away. It just went dead silent on the other end of the phone. I knew right away. He did not know that when they signed that contract. He thought he could push buttons in a certain way and he was going to get this from his GPS. And I know for a fact that his company did not have geodetic quality leveling equipment, the geodetic quality level, and much less the rods. And then to have to go through the procedures. I know this guy and his company had never gone through any of that. And right away, I knew what was going to happen. He was going to put that phone down and he was going to have to sit there for a minute and compose himself and then go to the next office where the guy who owned the company has his name on the letterhead and tell him, we bit the big one here. So it's really important to understand not only when, if somebody comes to you and says, oh, I want heights and they'll often quote, and I've heard this quoted many, many times. Somebody will quote, oh, I want first order heights or second order or third order, because that's what they've heard. They don't really know what it means, but they've heard it. So that's what I want. And to me, it's important that the surveyor makes sure that they understand what that is. And they're educated in, well, I can give you that, but if you want first order or second or even third order heights, it's probably going to cost you way more shekels than if we do this with GPS and we get this level of integrity. So you got to be cautious about how we approach all of these things. Now, I like to put this in simply because, again, I came from the background in horizontal, and we had huge instruments. I ran a T4 for much of my Army career, and if you've ever seen a T4, it makes a T2 look like a compass. It's big, and you have to set it up, and you're out there observing all night. And so we had cool toys, and we had all kinds of different theodolites, and we had EDM, we had towers, whatnot. Leveling hasn't changed really in the better part of almost 200 years. It almost all looks the same. The toys are way different. Now, I love the pictures on the right. These are coast survey guys out doing geodetic leveling. And I put these pictures in here for just to remind us that, okay, the leveling was all done optically. And it shows you, not that this is a particularly big point, but we're very proud of it. The instrument that you see there is called a Fisher level. It's the only geodetic level, the only one that's ever been designed and manufactured entirely in the United States. It was pretty cool. Let me see if I think I've got a link here to a better picture from the Smithsonian. Yeah, there you go. The Fisher level, pretty cool stuff. But the process of leveling really hasn't changed. The geodetic digital barcode levels that we see now, in my humble opinion, are the finest surveying tools that have ever been made. Especially if you're doing geodetic leveling, and I don't care which one of them, I don't care if it's a Trimble or the Leica, doesn't really make any difference. They're both phenomenal tools. And if you have errors, 99% of your errors come from your procedures. The instruments are near perfect, near perfect. So I put these in just to reflect on that fact that leveling has not changed and isn't going to change, right? So to approach it from that perspective, and we think about the heights that we have that represent the National Spatial Reference System today, those that define the datum were all defined by leveling, right? Now, this issue of heights from GNSS, there's some issues that a lot of people don't really think about when they go out. And regrettably, and I've seen this far too often, surveyors and others are guilty of what I have come to call buy-in on Friday, working on Monday. And I've known hundreds of surveyors across the country that from one point or another, I'd be out somewhere and talk to them. No, I don't need GPS, I don't need to have that. Blah, blah. I'm doing fine with what I've got, blah, 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 all that. And then some job would come up and they go, well, I probably should have GPS for that. And they call the local supply house, their local dealer, whoever they like, Trimble, Topcon, Leica, whatever. And they'll say, have 4 receivers in the office by Friday afternoon. And the guy takes them home, pulls them out of the box, turns them on, gets the book out, thumbs through the book, gets a 6-pack and makes sure all the receivers are operating, and Monday morning they're out working. And have rarely gone through much, if any, training on not only how to use them effectively, but what does the data mean when it comes out? Because that's really the important part. Because any fool can go out and punch a button and get a number. So what does it mean? And how am I going to use this in the most productive way? And some of the limitations, horizontally, we have, with the exception of being very close to a building or some other large structure where you're going to get a lot of multipath, we can go almost anywhere and get great horizontal. We can do centimeter or better positioning horizontally virtually anywhere on the planet, with limited amounts of time. It takes almost nothing to do horizontal. Vertical, it's a different case. The vertical, we're limited by that geometry, that satellite geometry. And it's because we'll never get the satellites that are under us, obviously. We're never going to get those. We're only getting the satellites in the constellation that we can see. Well, they're not always the best geometry. So that's a problem. Obviously, atmospheric contexts have an effect on it. Antenna phase centers, surveyors not understanding or having a good handle on the types of antennas and their phase centers, that's vitally important. NGS produces all the phase centers for basically every geodetic quality antenna that's being sold on the planet. A lot of those folks send it to the NGS facility in Corbin, Virginia, and they go through a rigorous testing process to produce that. The orbits, this is crucial. The orbits, if you really need to get good GPS-derived height, GNSS-derived heights, the orbits you're using are important. So obviously, when you're out in the field, you're getting the broadcast orbits. That's the informational orbit information that's coming directly from the satellites as they're broadcasting. Then you get the ultra rapid, which comes out about 4 hours after that, and that gets better, and it helps in the horizontal, and not so much in the vertical. If the vertical is really important, you want to use either the rapid or the precise orbits. The rapid orbits are typically available about 17 hours latency, something like that. It varies a little bit. The precise orbits, what you used to have to do when we would give workshops on GPS-derived heights, well, back in the day, we would always say, if you really want good heights, you must wait for the precise orbits, and they would take 2 weeks to be accumulated from tracking centers all around the world. Today, what's referred to as the rapid orbits, at least of the GPS, are so good that the difference between them and the precise orbits it's almost in the noise of the data. So if you're using tools like Opus, great tools, wonderful stuff, right? And heights are critical. Make sure that when you get your Opus solution back, it says right up there on the header record that, yep, you're using at least the precise orbits. The rapid orbits. That's a critical component. And then just in the equation itself, there's some minor uncertainties that need to be resolved. And I'll talk about those here in a second.
Can you just
mention the geoid?
Dave,
oh, sorry.
I was just gonna say, can you talk just real briefly about the differences in the orbits? Like, what's the difference between an ultra and a rapid and a precise? Like, removing what's getting removed, I guess, from or getting better data from one or the other.
Let's start off with the broadcast orbits, because what's happening with the broadcast is the satellites say, hey, here I am, here I am, here I am, here I am. Well, the orbits are uplifted to the satellites I think it's twice a day now. It used to be once a day, but I think it's twice a day now by the Air Force. So at 2 points during the course of the day, the satellite knows exactly where it is. Within literally nanoseconds after that happens, the satellites start to deviate from that perfect path that they are predicted to be on. And that becomes the broadcast orbit. So you have some error associated with where the satellite is as opposed to where it was supposed to be. Right? Now, the ultra rapid orbits, there's a network of tracking stations that NGS and others, there are any number of institutions around the world that compute orbits. So there's a series of tracking stations, and you'll look at them locally. Right? So across the United States, when I say locally, I'm talking about like the whole United States. And there's a small set of stations that are tracking the satellites all the time. And those can be downloaded very quickly. And I'll just use NGS as the example. So Part of the staff at NGS will download those observations fairly quickly. And by the time you might get back to an office 4 or 5 hours later, they will have better orbit values than the broadcast orbits. The rapid orbits use a little bit larger network. Again, it's contained, at least for us, it's contained within the entire United States. So now we get, within about 17 hours, we get the tracking network that says this is where this station was within the context of the tracking network just in the United States. The precise orbits use the entire tracking network all the way around the world. And that requires about 2 weeks for all that data to be observed and processed by each of the individual institutions that are submitting that data to whether it's NGS or any number of the other organizations that are doing this. So it's the local tracking network versus the complete global tracking network. And it's that, and I'll just highlight, it is that complete global tracking network that makes GPS, Galileo, and even the Chinese Beidou so good. It is still the one sticking point for the Russian GLONASS, because they've got a pretty good tracking network on their side of the globe, and not so much over here. You know, so still some issues with GLONASS. So hopefully that explains that.
Yeah, no, that was absolutely perfect. Zach raised his hand, so he's got a question there.
Yeah, Zach.
Yeah, hey. When you were talking about noise and interference there, I was actually looking for a voltmeter, a multimeter the other day, and I saw the difference. One brand offered RMS values, and the other one offered true RMS values that kind of account for the, like, realistic noise.
Okay.
Is that anything that's kind of considered in how the systems work? Does that make sense? Am I way off there?
Anything that is electronic, I don't care if it's a radio. Well, satellites are radios. I got a great kick out of Mike's presentation 2 weeks ago on Mentoring Mondays. He talked about how the BLM had invested early on in using geodometers to measure distances. And geodometers measure with microwaves. And I remember we were sitting around the office. This is early 80s, where, you know, the first satellites had already been launched. And we were talking about this, and I was still pretty new to the satellite geodesy game. And the more the folks who were working on it were describing it, and they, of course, they focused on it, it's basically a radio station in space. It dawned on me, GPS satellites are no more, not really, than geodometers, teleurometers in space. That's really all they are, you know, as they're broadcasting a radio wave. So anything that broadcasts like that has some noise in its information. Your cell phone has noise in it. So that's just a part of the electronic world. And you can try and minimize it, but you can't get completely rid of it. So invariably, anything we do that's involving electronic signals is going to have some noise. So it's a matter of how much does that noise impact what you're trying to do. That's what I meant by that. By and large, with GNSS, we've got a pretty good handle on that. The manufacturers, most of the manufacturers, do an awesome job in keeping the noise level down to a real minimum. Now, I mean, we're going to start to see more of these, and that's where surveyors will have to be a little bit cautious about what they're buying. But at least all the big manufacturers that we all know of now, they do a magnificent job of keeping that noise down to a minimal level. Let me give you an example. I've got a good example of noise like that. 1993, NGS was observing the HARN, the High Accuracy Reference Network, in the state of Virginia. And the Virginia DOT, they were big players in helping with that. And we had Trimble receivers. They had a different brand. I'm not gonna go into that. They had a different brand. That's okay. You know, as long as we know what the brand is and we know the antenna, good to go, no problem. we ended up finding that we were having a really, really, really difficult time with their receivers, particularly in the vertical component. And it didn't make any sense because the antenna reference points of all of those antennas, not individually, but the models supplied by the manufacturers had been done by NGS, and they were using the correct model. We couldn't figure it out. We worked on it for weeks. And finally, one of the guys at the research station in Corbin, Virginia, sat down with one of the manufacturers, the technical folks from the manufacturer, and they found out something kind of interesting. Evidently, this particular antenna was noted for building up heat. It didn't have an effective way to remove heat when the antenna was turned on. And a number of buyers had noticed this, that they were getting erratic results, and they were sending them back to get repaired. And what the manufacturer decided to do is they put what amounted to a tiny little fan in there to reduce the heat, to remove the heat. That tiny little fan changed the antenna reference point. So it was noise. Noise in the data changed the antenna reference point. Once we recognized what that was and simply went back and then recalibrated the antennas, everything worked out. But that was another example of noise, minor noise. You never would have noticed it, you know, but it had a big impact. So
interesting.
Well, that's the noise component.
Thank you. I've just kind of been wondering about that lately.
Sure. It's a good thing to work
on. I appreciate it.
Sure. So I mentioned this issue earlier, the geoid. You know, do we know what it is? This is crucial. This is really, really, really crucial stuff. Now, this is the kind of stuff that entire advanced degrees in geodesy are built on. You don't need to do that. You don't have to go to Ohio State and take a PhD or New Brunswick or one of those places. You know, all you need to know is this. This is one of the holy grails in geodesy. The geoid, not necessarily what we have now, but the geoid is this: equal potential surface of the Earth's gravity field, which best fits global mean sea level. That's what we want, not what we have, right? We've got something different. If this does not roll off your tongue, you're a GPS user, GNSS user, and this does not roll off your tongue, one of the best recommendations I have is next weekend, you go out shopping or something, go get that tattooed on your left arm. So it's always right there. You never forget it. This is important stuff, right? Because an equal potential surface is what we're looking for. Water will not flow on an equal potential surface. That means the potential of gravity is everywhere the same. That's not what we get from leveling. It's close. It's close, but it's not what we get. Right? So this is also part of the problem with GNSS-derived heights, and at least right now in the US, exclusively GPS-derived heights. And I'll show you where that comes up in a moment. So we do not have this yet. We will with the new vertical datums, and I'll mention that at the end of the session. Right now, NGS has two different types of geoid models. And people are always banging on NGS looking for that next best geoid model. I want that model, so I can go out and I can do accurate GPS-derived heights. That's what they want. Well, when NGS builds a geoid model, they build two types. They start off first with just gravity data. That's all it is, just gravity data. In fact, that's what we want. That's what we really, really want. The problem is that model, a gravity model, does not look like NAVD88 when you use it, or any of the other vertical datums that we have in the United States, whether it's Puerto Rico or Virgin Islands or Hawaii, it doesn't look like it. Because vertical datums, as I mentioned earlier, are based entirely on leveling, not gravity data specifically. Gravity is used to help reduce the leveling, but they're not defined by the gravity data. So to make a geoid model look like you're tying into an NAVD88 benchmark and you're out on some project and the closest NAVD88 benchmark is in the head wall of a bridge 7 miles away, you're left with a choice. Well, I can run levels 7.5 miles to bring that control in, or I can perform some GPS observations for literally a few seconds and get a pretty good height right here if I apply that geoid model. Will that satisfy my requirements? Well, duh, almost everybody's going to go, I don't want to run those levels because it's expensive and nobody wants to pay for it. You know, you go to a client and say, hey, it's going to cost you $4,000 for me to go run those levels. They're going to, we all know how this works. Right? So to achieve what we have, NGS builds we refer to as a hybrid model, compositor, hybrid. That's what every surveyor has dealt with. When they get the new geoid, latest and greatest geoid model, that's what they're getting. And I've got just several of them listed here. Our first one was Geoid 93. It was very bad. But Geoid 09, Geoid 12A, Geoid 18, which is the current geoid model, is a composite. That is, it starts with the gravity data, and then NGS uses GPS on benchmarks that have been submitted to them for publication as part of the National Spatial Reference System. And I'm going to show you in a minute where this gets a little strange. So when you're going out and using a geoid model, it's this composite or hybrid model, not the real geoid. Right? That's what we're going to for the new vertical datum come, well, 2025 is probably going to be the release date now. So understand that when you're out there and you're punching buttons, what you have in your data collector, Geoid 18 probably, is this hybrid. And its accuracy and integrity is based on the amount of and distribution of GPS on NAVD88 benchmarks around your area and around the country. I think that comes up here. No, I've got a couple. So let's just kind of understand what these different heights are, all right? So here's my little representation of my GPS receiver. And this brown line, big H, that's the orthometric height, NAVD88. That's what I want. This green line that you see down here at the bottom, the squiggly green line, and I said it's the geoid. And in parentheses, I mean, it quotated there, I've got average mean sea level or the NAVD88 surface, or if you're in Puerto Rico, it could be the Puerto Rico datum surface. It would be one or the other, right? The difference between those two is relatively small, but really important. So in the context in which we're dealing with today, the green line represents the surface of NAVD88. With the new vertical datum coming in 2025, NAVD88 goes away, and it will now be the geoid based purely on gravity data. Right? So I want big H. That's what I want, because water is going to flow in, well, I can trust where water is going to go if I know what big H is. If I have two height differences and they're both in big H, that is orthometric heights, I can pretty much predict where water is going to flow. Right? That's pretty simple. I don't get that from GNSS GPS observations, which is little h, which is this green line. Right? And as I pointed out previously, if I want to get a GNSS, GPS-derived orthometric height, I now have to add the geoid model, this geoid separation, capital N. And it comes from a model, an estimate. All models are estimates. So how well I know a little h depends upon how I perform my GNSS observations. And there are tools to help you do that. How well I know the integrity of N is completely dependent upon how much data goes into the model. So if there's lots of data, you know it pretty well. If there's a limited amount of data, a lot of it becomes a guess. So you kind of have to have a feeling for how well does this work in what area you're working on. And just up here in the upper left, I put in the designations for what that means, not only today with NAVD88 and NAD83, but also for the new vertical and horizontal datums coming in 2025, because they're coming rapidly. So how have we realized our vertical datum? Well, to start with, to begin any survey, you've got to have control. Everybody knows that. And as surveyors, and I love this part of it, I don't care if you come to surveying from the perspective of geodetic surveying like I did, or from land surveying. It has always been about the monument controls. And we love monuments. As surveyors, we love monuments. I love monuments. I have a collection of brass caps from around the world. I know for a fact that the gravity field in my family room downstairs takes a dip because of my collection of brass caps from around the world. But the way we have accessed the reference frame historically is always through passive marks. And I've just shown here some pictures of some of my favorite passive marks that are part of the National Spatial Reference System. This one down here in the bottom center, benchmark A, that's the original primary benchmark of the United States. It's in Hagerstown, Maryland, not too terribly far from where I live. Still there, you know, and so we started leveling going across the country in 1877. So this is how we've accessed marks. They've been great. The problem is that once a height or a position, but in this case heights, are determined, and they're well determined, unfortunately, there have been not much in the way of NGS having the capacity to go back periodically and remeasure them to make sure that they're in the same place that they were when they were first set in, like this one in 1877. So NGS provides you a height. That height could easily be 60 years old, 70 years old. That's not at all unusual. Are those benchmarks 60, 70 years ago? Are they in the same physical location as they were when they were first set? Who knows? We have lots of areas of the country that are undergoing either subsidence or uplift for a whole set of reasons. So how much can we trust a lot of the passive marks? That's always a problem. And I put these in because we've all known it. We've all seen control, you know, that's been busted up. We know that this is a big part of it. And so trusting the passive vertical control is and continues to be a problem. That's why it will go away with the new vertical data. So what do we use now? Now we can use the cores, continuously operating reference stations. Well, they're great because first of all, many of them, especially like the one on the left-hand side, that's the NGS station in Corbin, Virginia, that's been operational for 16 years or something like that. So we know where that puppy is. And if something is moving, whether it's laterally due to plate tectonic motions, or it's vertically, you know, as we certainly see in the Chesapeake Bay area, not far from where I live, or the Gulf Coast, parts of California, I mean, Alaska, oh my God, you know, we can detect them because we know literally every few seconds, we know the position of these monuments. So we can start to track them with cores. Now we can't do that at the millimeter level, not yet. Not yet. We're getting there, but not yet. With the passive marks like these, you have to go back and remeasure them at a very high degree of integrity to know if any motion's been going on. And again, there are no systematic procedures to go ahead and do that. So it's been a problem at NGS to actually detect and understand vertical motion. But now we can do it with cores, but they have some limitations. Minor, but still limitations. So this geoid model, right? Remember I said we have a hybrid, and that hybrid is based on GPS on benchmarks. That is, somebody's gone out to the field, found an existing NAVD88 first, second order benchmark, and has now occupied it with GPS. And that data has been submitted to the National Geodetic Survey for inclusion in the National Spatial Reference System. Now, what you're looking at here is a picture of each of the little red dots you see is a representation of GPS on benchmark for Geoid 99. You can see there's roughly about 6,200 of them. Well, 6,200 GPS on benchmarks is quite a bit, but we're a big country. And I'm going to go through a number of these. I want you to pay attention to the changes. They'll be obvious. look at the areas where you see a lot of red dots, right? Maryland and New Jersey, down here in Florida, Minnesota, we're starting to see some here in Colorado, Harris Galveston. I don't even like to talk about the Harris Galveston area, just dropping like a stone. That's a tough area to deal with. But I want you to look to watch this and see how things are evolving, right? So this is roughly 1999, 6,100 GPS on benchmarks. Now I'm going to move forward to 2003, so that's 4 years later. And in that interval, we're now going to add 8,000 GPS on benchmarks. Now, watch where things are happening. And now I'm going to move forward from Geoid 03 to Geoid 09, 6 years. And we're going to add another 4,000 GPS on benchmarks. I hope you're seeing a pattern. They're all happening in the same place. So I'll just highlight Minnesota, right? So let's go back. Watch Minnesota. Geoid 99, Geoid 03, Geoid 09. A lot of work happening in Minnesota. I like to joke about it that if you ever happen to go to Minnesota and you stand still for more than 45 seconds, somebody from MnDOT will come out and position your butt. These guys they're nuts, but they do awesome work, right? So I want you to look at that. Now I want you to look at Utah. So Geoid 99, look at the number of little red dots in Utah. Geoid 03, Geoid 09, not much, not much. Nothing is happening in Utah, Nevada, Wyoming, Idaho, Montana. Well, I shouldn't say South Dakota because they did a great job, but those are all the benchmarks they have along those roads. That's it. But look at the number of states where there's a lot of white and not so much red, right? What that means is the areas where there's red, there's more GPS on benchmarks, hence the geoid model is going to be a lot better. And I'm going to go forward in time a little bit to Geoid 12. They changed the format of the map, so it doesn't look exactly the same. But again, you see most of the eastern part of the country, a lot of GPS on benchmarks. Western part of the country, not so much, right? Big thing happened with Geoid 12. Big thing happened. Everything back here and previous to that, all of that data had to be what's referred to as blue booked. That is, the surveyor performing the observation goes through the procedures, follows NGS guidelines, and submits that data through a technique known as blue booking because the book has a blue cover. Right? I would suspect that if we have 40 people online, as Trent had indicated earlier, I would suspect that maybe one person might have actually blue booked a project. I would not be at all surprised if nobody on this presentation tonight has ever blue booked a project. Let me give you my version of an example of that as to what blue booking is like. Go outside, get a stick from a tree, take your pocket knife out, sharpen one end, and jam it in your eye. That's what blue booking is like mentally. It's tough. It is tough stuff. The point is that NGS holds this national reference frame, and we have no field parties anymore. The NGS, I should say, no field parties. They've got a tiny number of folks in the field. When I joined NGS in 1972, we were knocking on the door of 1,000 employees at the agency, and well over half of that was in the field, leveling parties and triangulation parties. Now I think the agency is down to 6 people that they send to the field, and the entire agency itself is 180 people, something like that. So NGS doesn't go out and do this anymore, right? They don't do that work. The work is done by private surveyors just like yourself and submitted to NGS, or it's done by state agencies or what have you. So up until this point, the only way to do that is go through this very difficult process. In Geoid 12, for the very first time, NGS opened it up to people submitting their data through Opus. And if you selected Opus shared solutions, I'm relatively confident that everybody that's listening to this tonight has at least used Opus once. You know, you've gone out to the field, you sat there for 15 minutes, and maybe you sent it to Opus RS, Rapid Static, or maybe you sat there for a couple of hours and submitted it to Opus S, Opus Static, you know, and it's simple, you know, it's bone simple. I mean, if you've got the IQ of a sweat sock, you can submit data to Opus. In 2002, the agency opened it up so that we could now do submissions from anybody, basically, and actually publish that data. So NGS has a separate database that houses data that has been submitted for publication by surveyors just like yourself. And if you've never done it, I highly recommend that you take a look at it. Now, the concept of how the Geoid has improved from Geoid 12A to now Geoid 18 was because of surveyors, just like everybody that's on here, going to the field, performing those GPS observations based on the outlines that are on the NGS databases. So you got to sit on a point for 4 hours, and then you submit it to Opus Shared Solutions. And between Geoid 12 and now Geoid 18, and again, they changed the format of the map on me, now we see more GPS on observations. So where we are right now with our current Geoid model, Geoid 18, the integrity of it, the accuracy of it is going to be defined by this: the number of and density of GPS on benchmark. So if you're up here in Minnesota, Wisconsin, parts of Michigan, a lot of the East Coast, Geoid 18 is probably going to work pretty well. If you're out here in the western part of the country, it's going to work pretty well if you're close to one of the benchmarks that was actually used in the model. And I'm going to show you how to check on this in just a moment. So this is the way things have been. Now, at this point in time, NGS will never, ever, ever do this again. Hybrid geoids are done. Geoid 18 was the last one. It'll never happen again. Next time NGS develops a geoid model, it will be called Geoid 2020. Right? They've already named it. That will be coming out from the gravity data that's going to define the new vertical datum that will come out in 2025. And I'll talk about that at the end of the session. So for both Geoid 12 and Geoid 18, now NGS at least provides some tools where you and other surveyors can go in and go, well, how well is this tool performing for me wherever I live? So they have a map, first of all. So this is a nice map that says, well, I can look at this map, and if I'm in an area that's more green than yellow or orange, well, I'm probably pretty good to go. If I'm in an area that's more orange, I can't necessarily trust that model down to the millimeter level. And I say that because every time you use the tool, whether you're looking at an NGS data sheet for a passive mark, or you're actually typing in the Geoid 18 tool and getting that number for some point that's out in the middle of nowhere that you've observed, every time you do that, the value of the Geoid separation is going to come out to the nearest millimeter. And if you don't know any better, if you don't, you don't know this map, and you don't look at the other Geoid tool, you're left with saying, well, NGS gives it to the nearest millimeter. It should be that good. NGS provides these tools. It's up to you to know where they are and use them in the context of whatever it is that you're trying to accomplish. So here's the map. And let's see, I'm trying to remember where I put the tool. Ah, here it is. All right, so I just kind of random, well, not sort of randomly. I looked around, picked a passive control out there in White Pine County, Nevada. Never been there. I'm sure you know where that is. Out in the middle of nowhere, kind of is what it looked like. Yeah, okay. Now I picked this station for a couple of reasons. One is that it has been GPSed and it is in the National Spatial Reference System, and it's an old NAVD 88. I mean, it's a benchmark that goes back to 1934, right? So it was part of NGVD 29, it's part of NAVD 88. It has a very good first order class 2 orthometric height by Loveland. Right? That's a good station, should be a good station. All right? but it's also been GPSed. And NGS provides you that information. So I want to put, I put this little block in here to show you some of these differences. So from the GPS, we get the ellipsoid height. I'm just going to do this metrically, and I hope nobody's metrically challenged. I get 1956.774 meters. That's my ellipsoid height. So to fit it into the equation, big H equals little h minus n, there's little h. There's my ellipsoid height. Here's the geoid separation, the geoid height from geoid 18, our current model, shown to the nearest millimeter. Point that out, shown to the nearest millimeter, minus 20.610. So if I plug those into the equation, I come up with the GPS-derived orthometric height for this station should be 1977.384 compared to the leveling. Well, that's only 9 millimeters. Yeah, that looks pretty good. Now that's a comparison because you have a known point. You have a known NAVD88 height. If you're in a situation, and there are lots of areas where you don't have that, you're out in the middle of wherever, and you're collecting data, how good is your data? How can you rely on that height? That's what I want to show you. You need to, first of all, know how good your ellipsoid height is. So in this case, NGS shows you right down here. All right, so I've highlighted that. This ellipsoid height has a 95% confidence uncertainty of 1.4 centimeters. That's pretty good. That's really good. You will have a hard time achieving that. Right? 95% confidence. But you can come close. Right? The critical part is how good is the geoid model? Now, the model is right here, geoid 18 minus 20.610 meters shown to the nearest millimeter. How good is it really? NGS provides a link. It drives me crazy. They never tell anybody about it. You have to know it. And somehow it just had to fall from the sky and hit you in the head. NGS regrettably doesn't talk about it. And I have to admit, I don't often hear the regional advisors even talk about it. But the tool, NGS derives the tool, they put it online, you can go get it, right? I can show you this. On the data sheet down here, and I've chopped off some stuff so it makes it readable. The significant digits in the geoid height do not necessarily reflect accuracy. Geoid 18 height accuracy estimate available here. Well, you got to click on here, all right? So it's an estimate, right? If I click on this, where did I go? I'm going to do this. I'm going to go to Geoid 18. So here we are in Geoid 18. I'm going to go to interactive computation. And this is real simple.
That might be on your other screen, Dave.
Oh, is it? Oh, I'm sorry.
That's okay.
Okay, well, here's what I'm going to do. Yeah, if you can't.
You can drag it over, possibly. Drag that browser over to the screen.
Actually, I'm not sure how to do that. Well, let me just walk through it.
Reshare the other one, yeah.
If you do that, what you will find, and I did this very quickly, I'll just remind myself here, 39 and 24 and 115. If you take the coordinates right here and you go to the Geoid 18 model on the NGS website and you enter those coordinates, because that's all you have to do, it will spit you back out the geoid separation minus 20.60 meters, all right? Just like you see here, yeah, right there. But then right next to that, and you can't see it here, it says error, 95% confidence, 5.6 centimeters. So if you're out in the field and you're counting on it to be millimeter accurate, 5.6 centimeters. So obviously, and this is one of the stations that's in the model. That just means there aren't a lot of stations out there in Eastern Nevada that are part of the model. So the user, you need to be well aware before you even go to the field. If you're going to do GPS-derived heights, take a look at that model. Take a look at the tool. Go to the NGS homepage. On the banner up at the top, under Science, get the drop-down menu, Geoid models, go to it. All you got to do is do the interactive computation. You type in the latitude and longitude, boom. It'll give you back this number, and then right next to it, it will tell you what their estimate of the uncertainty is at the 95% confidence level. So know what it is before you go to the field and make any estimates about what you can or cannot do with deriving heights from GPS. Now, that's in an absolute mode. And I say that because the overwhelming majority of surveyors that I know, they go out somewhere, they might put in 1, 2, or 3 points, and maybe they're going to use Opus, so they get an independent solution, and they're not necessarily tied into a real-time network. And the geoid model is going to be an absolute at that point. You'll get good height differences between stations. The differences, the height differences in any given area, even where the absolute value might be, 5 or 6 centimeters, the relative height differences, they're going to be real good. But the absolute values, and if you're using this to do floodplain mapping or something like that, that's what you want, those absolute values, because that's where water's going to go. So you should be aware of that. Understand that that tool is there. Look at any one of these data sheets, and that same code, same node will be there. Go to it, check it out, do this little trial, and you will see, oh, where I live, oh, it's good to 3 centimeters or 6 centimeters or whatever it happens to be. And the rationale behind that, why it's so different from one end of the country to the other, is the amount of GPS on benchmarks, pure and simple. Anything that we do, I'm talking about the vertical component at this point, but anything that we do, horizontal or vertical, this, as a professional, this to me is mandatory. This should absolutely be mandatory. This should be tattooed on the other arm. You know? That coordinates and heights without the appropriate metadata, like I said, it has, to me, it has the same integrity as a boundary line in Google Earth, and we all know what that means. You know, it's a big ass guess. It's a nothing. You know, and what do I mean by the metadata? What am I really talking about? All right, really pretty simple. I mean, there are whole documents that are written about metadata that none of us understand. This is pretty simple. The datum and its realization. So if you're on NAD 83 2011, oh, put the epoch, because now we have epochs. In the future, we will always have epochs for both horizontal and vertical. So whatever the epoch of an observation is, the time component of it, the datum, right? I can't tell you how many times, I've seen some of these plats where somebody will say, I have state plane coordinates, Virginia North Zone, NAD 83. Okay, which NAD 83? The original one in 1986, or the Harn in 1993, or the 2007 National Adjustment, or the 2011 National Adjustment? Which one? You know, if I want to compare with that plat, I need to know that. You know? Now, maybe I could figure it out, but I shouldn't have to. It'd be right there on the plat. So the datum, that's vitally important. The units of measure. Meters, well, regrettably, we're not a metric nation, but one can hope. US survey foot or international foot. Now, right now, in state plane coordinates, that's a big deal. In the future, the new datum, horizontal datum, US survey feet, go away, done, finished, done, kaput. You know, everything will be in international feet, and actually NGS will just refer to it as feet. You know, international will go away. So that's important, the units of measure that you're using. And the accuracy. The accuracy. You put a coordinate, or you put a height on a plat, in a database, in a publication, I don't care what it is. How accurate is it really? As you see in my note, the number of digits to the right of the decimal point have nothing to do with accuracy. And is it 1 sigma, 68% confidence, or 2 sigma, 95% confidence? To me, as a professional surveyor, everything should be 95% confidence. That should be the world we live in, you know, so that there's only a tiny range that's beyond what we would do. And let me give you some examples of bad metadata that I have collected from professional surveyors and other professional institutions. Just a couple of examples of bad metadata. The one on the right, I love this stuff, right? Nice north arrow, and the reference is NAVD88. Now, I gotta admit, some of you may know this. I'm not ashamed of it. I was a deadhead. I'm a deadhead, right? I did 42 concerts with the Grateful Dead. You can imagine what that might have been like, right? On the best weekend I ever saw them, I've never figured out how you could get north out of a height, you know? So what I'm seeing from this is there's a professional surveyor out there who's just throwing stuff on a plat that doesn't know what it is. And that's not, we can't live like that, right? The one at the bottom, benchmark. First of all, I have a problem with singular benchmark. We own the word benchmark. It started with us. Other people use it, but it's our word. And it should be 2 words, benchmark. Okay, that's just soapbox for me. Top of concrete bound, elevation 73.68 GPS datum. What the heck does that mean? I have no idea what that is. I'm clueless as to what that person's trying to tell me. What unit of measure? I pretty much guarantee it's feet, all right? And the difference between US survey foot and international foot and a height like that, it's not going to be anything, but it should be there. I should know what it is. And what is the real datum? I'll share this one. I love this one. Now, this is kind of messed up and you may have a hard time seeing it. It's a publication from Fema. And I know every surveyor just thinks the world of Fema. Right? This came about, this is in 2007, so it's been a little while. I was managing a leveling program for the US Virgin Islands, that which ultimately created the Virgin Islands vertical datum of 2009. And we were at a meeting, we had a GIS meeting in the Virgin Islands in 2007. And the first person speaking at the conference on the very first day was the FEMA manager from that district, which is out of New York. They cover the Virgin Islands. And he went on for his half hour talking about the brand new floodplain maps that FEMA had just completed for the US Virgin Islands. And they were all in the next room. And at the coffee break, everybody could go take a look at the map, see what maps and see how they looked in whatever neighborhood you lived in. And when we got to the end of his his presentation, I raised my hand and I asked the question, how did FEMA create floodplain maps when there's no vertical control in the US Virgin Islands? Because there wasn't any. There had been some done back in the 40s by the US Geological Survey to do the topographic mapping. They had never been back. I had done the reconnaissance on all 3 of the Virgin Islands. We found 4 of those marks, and all 4 of them were in non-GPSable locations. So how did you create the floodplain maps with no heights? I'm curious, I'm a thinking boy, I want to know. Well, this guy was, he's a typical FEMA pencil pusher. And FEMA doesn't have anybody in FEMA as a civilian employee that knows much of anything about heights and maps, and surveying and mapping. They do everything with contractors. This guy points out the contractor that he had with him in a room. And this young man stands up and he goes, oh, well, we got a bunch of data from the Army Corps of Engineers. I'm like, well, okay, that's fine. I'm working with the Corps of Engineers and they're telling me how terrible their data is. So I said, well, would you send me a copy of this data? And sure enough, about a week and a half later, this nice little package shows up. This is from the flood insurance rate map study that they conducted. And they list the quote benchmarks to be used for the floodplain mapping. Now, I realize it's kind of messed up here a little bit, notes that I made years ago, but I want to point out a couple of things. And again, this is from a federal agency, and they are supposed to be authorities on heights, particularly, of course. So right over here, it says NGS PID. That means the station, this mark, is in the NGS database. NGS at that time published no heights, no accurate heights. Everything was scaled from a map. We published no heights for any mark anywhere in the US Virgin Islands. Elevation in feet, local title. So they're saying it's a local title datum, but they don't tell you what title datum, mean sea level, mean lower low water, mean high water. They don't tell you the origin, that is what tide station was used. And here's the value out to 4 decimal places in feet. 144.0636 feet. The first time I saw that, I'm sitting at my desk and I'm looking at that, these guys are righteously good. Who does that? as I went through it and I read this stuff, what I found is that in many cases, the marks were actually offshore. They were on rocks offshore. And I had to go digging through this, and they finally found a sentence in there that said it had all been done by photogrammetry. So they're generating heights with photogrammetry out to 4 decimal places. And that's what the surveyors in the Virgin Islands were supposed to rely on. And they have none of this information unless they really dig into this thing. So again, the responsibility of all of us as professionals. I don't care if somebody puts out 4 decimal places like this. I don't care. That's great. There could be lots of reasons you'd want to do that. But right next to it, tell me how good it really is. Oh, plus or minus a tenth, whatever. You know, you give me that, now I know what I can work with. But that's not here. And again, regrettably, I never see this when I'm looking at some surveyor's plat. I'm sorry that I have to say it, but I never see that. So to me, it's important. Yeah, put your values out there. Tell them how good it is. So that the next person that wants to tap into that has a good idea of what you've really done. So, okay. So if this issue of heights is important to you, then always do these things, right? There are other things you can do, but these are big. These are the big 4 for me. First, make sure you validate your existing control. That's vital. Had a surveyor in Beaumont, Texas, a bunch of years ago, 2009. He surveyed a subdivision and indicated that none of the houses and none of the buildings in the subdivision needed flood insurance because they were all out of the flood zone. He had tied into a single one Coast and Geodetic Survey benchmark, certainly published out to the nearest millimeter. The mark had subsided about 3 feet, and he had not validated it. And the entire subdivision got nailed in a big storm, and he got nailed subsequent to that. So always validate whatever control you're going to use. Make sure that you're not just grabbing one thing. You validate it with something else, just like you would a property corner. Right? You're not just going to accept something if without trying to validate it. Do 2 sessions. Minimum of 2 sessions, offset by at least 4 hours so you get a different geometry. Because remember, the only geometry you get is what's up here, is in our zenith. So having different geometry at different times can help you mitigate some of those issues. Always process with at least the rapid or precise, and really the rapid orbits. And that's about, like it says, about 13 to 14 hour latency. So if you want to get back to the office and you want to send something to us right away just to see how it looks, yeah, that's fine. But then, wait till the next day sometime and then send it back. Make sure you get that little note up in the upper left that says, yep, you got the precise orbits. And I've given you a link. You can see it there. And always, if you can, use fixed height tripods or antennas. Well, I cannot tell you how many times, so even I've seen in an NGS field crews, that people just didn't measure that antenna height correctly. So to me, those are the 4 biggies. Let me give you an example of that offset by 4 hours. This is a set of data that was observed during one of the state high accuracy reference networks, the HARNs. It's 2 7-hour sessions. Right? That's a lot of data. Right? And what the processor did was to take these 2 7-hour data sets and reprocess them in half-hour blocks. And you can see those day 264, everything starting at 2 o'clock, and then every half hour you see the process. And this is determining the difference in ellipsoid height, just the difference in ellipsoid height between 2 stations. Right? So you can see the differences that were observed in each one of those little half-hour blocks. So if we add them all up, you do the math, what you find is you come down here to the truth of all of these, 14 hours of observations, the truth being minus 10.276 meters between these 2 stations. 14 hours of data, that's a lot of data. You can rely on that. So if you take 2 sessions on the same day, at the same time, even on different days, but they're right next to one another. They're not separated by 3 weeks, but they're 2 days back to back. Yeah, there are different days, and they're certainly separated by 4 hours, but they're the same time in both days. If you look at the height differences, 10.254 and 10.251, well, obviously they match at 3 millimeters. Everybody would be happy with that. You would be very, very happy with that. If you compare it to the truth, that is the full component of all that, it matches by 2.3 centimeters. Well, that's not bad. That's not bad at all. Now let's take a look at doing the same thing, but we're going to look at the orbits in 2 different time frames separated by 4 hours, not just 2 different days. So I'm going to use the first one and now a second one, and you can see that the 2 sessions, just compare them to themselves. The average of the 2 sessions, instead of comparing by 3 millimeters, they differ by 4.1 centimeters. All of a sudden, if all you looked at was that, you'd be kind of, like, wow, boy, that's not quite what I'm looking for. But look how it compares to the truth. Now you're back to that millimeter. Now, I'm not going to sit here and tell you if you do this every time, you're going to get millimeter height difference. That's not what's going to happen. What it will do is by following this procedure, it will minimize errors in the heights. Okay? So obviously, the better you want your heights to be, the longer you're going to sit there. If you're working in a real-time network and somebody says, hey, you can jump out of here and grab a height or a position and you're going to get it in 15 seconds, yeah, fine. Is that going to give you the absolute best height? No. Maybe you're going to want to sit there for an hour or 2 hours. I would highly recommend that if you have older data that you might be able to compare something like this, go back and take a look at it and compare it and see how things look. So this is just one example of how that 4-hour offset works. In addition, in this particular case, they used the precise orbits because it was a number of years ago. You don't have to do the precise, you can do the rapid orbits now. So what you can't do, what you cannot do, and not only can you not do it today, you'll probably never be able to do this. Currently, as it says, you cannot achieve orthometric height standards based on the Federal Geodetic Control Subcommittee national standards, standards and specifications for geodetic control networks, first, second, or third order. You just can't do it, right? Now, let me give you an example. And I'm going to use the least of the examples, third order. So let's say you want to go to the field, you want to try and get third order, okay? Just third order, not first or second, just third. Well, here are the standards from leveling. Okay? So third order is the lowest, 2 millimeters times the square root of k, k being the distance, km, the distance in kilometers between any 2 points. Okay, 2 millimeters times the square root of k. So I'm going to take a station. I want to get third order for 2 stations that are 10 kilometers apart, 6 miles. Well, that's not unheard of for a lot of surveyors. We're observing 6 miles RTK or pretty much anything like that. Just go through the math. It's real simple. You'll see that what you would be allowed for to even begin to call a survey third order, you would be allowed 0.02 of a foot, 95% of the time, 95% confidence. What's the likelihood that any of you out there are ever going to get 0.02 of a foot in heights, 95% confidence? Yeah, this ain't going to happen. Not going to happen. So again, be cautious. I can't say this enough. Be cautious of when you're getting some data from somebody. I don't care where it comes from. I don't care if it's coming from the feds or the state or next surveyor next door or whatever, and it's out the 4 decimal places, or somebody says, oh, I got second order stuff or first order. I've seen this stuff mixed in a million different ways over the years. Just make sure that raises a hackle. You go, I don't know. I want to look at this real close. Don't just accept what it is. And the same thing, if you're giving data to somebody else, make sure you give them that right metadata, so that they know exactly what they're trying to compare with. George, there are 2 documents out there.
George has a question. George has a question. So
George,
before you get on.
Well, it's more of a statement than a question. First of all, I want to thank you for this presentation. It's really helped me understand what I do know and better understand what I don't know, which is a big deal. But as a water rights surveyor in the wonderful unpopulated state of Nevada for almost 40 years, we found a solution to this elevation problem with where water and fluids go. They go uphill to money.
Exactly.
Good on you. I wish that worked everywhere.
Right.
Yeah. So again, highlight to make sure that whatever data you're giving to a client or sharing with somebody else, that you've properly addressed the issue of metadata, you know, in whatever form that works for you or your company or however it is. And again, really highlight and talk to your friends about it or however it works, that as you're getting data from somebody else, that again, I don't care how many digits to the right of the decimal point there are out there. You want to put 10? I don't care. You know, just make sure you say, oh, it's good to a tenth of a foot, 95% confidence. You know, okay, fine. Then I know what you got. I know what it is for real. Right? There are 2 documents NGS provides. If you really, really, really want to get into the nuts and bolts, particularly doing networks and getting the best you can get of GPS-derived heights from networks, there are 2 documents. NGS manuals 58 and 59. So all you really have to do is go to the NGS website and just search NGS 58 or NGS 59, 2 different documents, guidelines for establishing GPS-derived ellipsoid heights, and another one for orthometric heights. And much of what I've discussed here is reiterated in those. So you can have those documents, you can link them and download them and peruse them. I know NGS has been looking on trying to update this, but I got to tell you, with everything NGS has done and the various webinars that they've put on and folks that I know that I stay in communications with, I have yet to see where they have come up with anything yet that really improves on either of these 2 documents. Now, I'm sure something may happen with the new vertical datum. That's highly likely, but that's still a couple of years down the road, and they've got some research they need to do. I wanted to end my presentation by talking about the future. I've talked about where we are. Now I want to talk about where we're going, and we're going to get there quick. Now, this should have been done next year, but COVID and a variety of other things have pushed NGS back a couple of years. The vertical will be a transition beyond anything we've ever seen. All vertical datums everywhere in the world have always been defined by leveling with respect to 1 or more tide stations somewhere within the context of the datum. That goes away. It does not exist anymore for the new datum. It doesn't, leveling doesn't exist. Leveling is still high priority. NGS is never, ever, 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 ever going to come out and re-level your community. I don't care where you live. That's never going to happen. Those days are long gone. Right? In 2007, NGS put all of our technical advice together. We all sat around a room, came up with new ideas for what we thought the future was going to look like. And several of us, many of us actually, who were part of the development of both NAD 83 and NAVD 88. I was on the architecture team for NAD 83. We ultimately had to come to the conclusion that neither one of those datums will fit the technologies that are coming literally right around the corner. Right? So we need to do something. That's why NGS has been so aggressively involved in a variety of activities to address this issue. The vertical datum of the future is now going to be based purely, exclusively on gravity data. Technologies have developed in the last 15, 18 years that were obviously never available before, and now actually bring this to a place where we can achieve terrific heights, terrific height quality without leveling through observing gravity. And it's referred to as this gravity for the redefinition of the American vertical datum. NGS has been flying airborne gravity since 2008, and they're pretty close to done, actually. So the foundation of this is based on 2 satellite systems. One is the GRACE system, which is pretty phenomenal. It really began the whole thing, Gravity Recovery and Climate Experiment. The data about the Earth's gravity field that come out of the original GRACE, which ended in 2017, to say it was spectacular does not do it justice. It was beyond anything anybody could have ever conceived of. One of the biggest problems we've always had with gravity data and this goes right to the heart of generating the geoid models, is we could never get good gravity data in the nearshore environment, or certainly in transpolar areas. It's very difficult to do that. It's very difficult to get good gravity data up and over mountains. You know, to get the best gravity data, we would literally have to have a team of observers go out and replicate the original PLSS. And you can imagine what that would look like today. First of all, it just couldn't be done. You know, so that's not. Now using these space-based systems, we get this incredible picture of what the Earth's gravity field looks like that we could never have done before. So the original GRACE went up. It went up in 2002. It's a pair of satellites, and you kind of see that in the picture. You can always go to the, if this doesn't do it for you, you can always go to the NASA site and just type, you know, Google GRACE satellite. It'll there's all kinds of stuff out there. It's hard to see here, but right there on top of this satellite, there's the GPS antenna. So all these are controlled with GPS. We also use the European version of this, GOCE, Gravity Field Steady State Ocean Circulation Explorer. It was up for 4 years. GRACE was up for 15 years. It came down in 2017. It's now been replaced with GRACE FO, or follow-on. And when I talk to the folks who are involved in the gravity side of this, that's the physical geodesy side, not my side. They tell me that the GRACE follow-on data makes the GRACE data look trivial almost by comparison. So we are really expanding our knowledge of the Earth's gravity field. But when we do this from satellites, we get a big picture. We don't get the tiny picture that we need to be able to go out and generate local heights. We get the big picture of what the Earth looks like. So the idea here was to combine the space-based observations with observations on the ground. Here you see a couple of pictures of some absolute gravimeters, an FG5, micro G FG5, or an A10. These puppies are hundreds of thousands of dollars, right? So, you know, most people don't have them in the back of the truck. But with a strategic network of absolute gravity stations controlling airborne gravity across the country, now the idea was we could predict what these orthometric heights would look like purely by gravity data. And NGS conducted 3 field surveys, one in Texas, one in Iowa, and the last one in Colorado, up and over the Rockies, to validate that, yeah, we can do this. And all 3 of these surveys, which included brand new first order leveling, brand new GPS, brand new gravity data, and comparing it then with what the predicted stuff was from this project, everything matches within amazing tolerances. So we're on the edge of some really, really phenomenal stuff coming shortly. The agency is, well, probably by today, they're about 85% done. Nevada's not done yet. I don't think it's been flown quite yet. The first part, when we never knew if the funding was ever going to hold out, so the agency had priorities first. One was was Alaska and the coastal areas, because there was always an offset in the gravity data from the nearshore environment to the land basin was never able to resolve, and now they can do that with the airborne gravity. So if we lost funding, we'd at least be able to do that. I talked to the program manager about this about 3 months ago. He's quite confident that they will finish all the airborne gravity probably by the end of maybe 21. They're really hopeful to be done by the end of 21, maybe middle of 2022. So we're getting real close.
Got a couple of.
So what is this?
Got a couple hands raised. Zach,
yeah.
Zach, and then Mike. Go for it, Zach.
Yeah, Zach.
Sorry, looking for the mute. Do you think that they'll eventually be able to incorporate like the new SpaceX Starlink constellations into what we use day to day, or?
If I'm not mistaken, that's an independent service. Is that correct? Mm-hmm. Yeah. See, I mean, NGS can, the private sector can go out and pretty much do whatever they want. Mm-hmm. NGS doesn't get in the way of that. NGS does not get involved directly with any real-time services whatsoever, other than to provide the cores and the integrity of the cores. So this has always been a big issue at agencies like NGS, which is competing with the private sector. So if somebody wants to go out and put up a model to provide real-time control, that's up to them. NGS doesn't get involved. And what NGS does do is periodically they like to hold events where they try and bring these people together to say, okay, here are best practices that we recommend, but NGS has no way of either ingesting that data unless they bring it to NGS and do so, which almost nobody ever does. Okay. And certainly NGS can't dictate to anybody what they do. So whenever you're using service like that, you just got to be aware of what the folks are providing to you. Does that make sense? I hope.
Yeah, it does.
Yeah. Okay, good. Perfect. And then there was somebody else?
Yeah, Mike Schroeder.
So
Mike.
I just have to comment that, you know, Alaska's been the neglected stepchild for geodetic projects for so many years, but
no.
Yeah, but this project was, you have to get some attaboys, because I know that I had a brief and lobby as a federal agency, and many others did in Alaska, and the state of Alaska stepped in with a big checkbook to get a lot of that airborne gravity there.
Yeah. Boy, when we first even started talking about this, even when it was in the planning stages, Alaska came right to the top immediately, because all of us who are on, well, I'll call it the senior technical side, and especially those of us who have done any leveling or on the vertical side, everybody knew that Alaska was just, it's horrible. Obviously, it's horrible. I mean, everything's moving all the time. You know, it makes California look like it's standing still. You know, and just the environment. Obviously, you know, speaking to the choir with you, just working up there, you have incredibly limited time frames, and then trying to do leveling, let's say out to the Aleutians. Give me a break. No, can't happen. So this has always been a problem, you know, in the great state of Alaska, is producing good heights. And so it came right to the top when we started addressing gravity. We said, well, whatever happens, because we knew this was going to be at least a 10 to 12 year program. And, you know, with you being an ex-Fed, you know, that one day you can be on top and the next day you got no budget. So we said, well, if we're going to do this, let's take care of our problem children right away. And Alaska and the rest of the shoreline areas of the country were right on top of that, Mike. And I appreciate the efforts that you and others have made to make that happen in Alaska. It's a big, big deal.
And then one other question. There was a lot of gravity that was collected from the space shuttle. It didn't affect a lot. It was like latitude 51 and south or something.
Yeah.
Was that rolled into any of this, or did they just use the...
No, it wasn't of the quality that was necessary for this effort.
Thanks, Dave.
Just didn't make it. So we are close. We are really close with this, and it will change the way you have to think about vertical control in the big context. So if I look at this, you know, so what does this GravD thing mean? Well, here it is. The datum is no longer defined by a benchmark at some location. Now, even though, almost nobody, even the Canadians, have ever been to Point Rimouski, which is where the origin point for NAVD88 is. I've been there. Yeah, there's a benchmark there, but any surveyor can kind of just take a second and close their eyes, and they can imagine a benchmark sitting in the ground with a brass cap in the top, and somebody says, oh, the mean sea level value of that benchmark is blah, 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 whatever it is. Anybody can imagine that. And even if you're out in the middle of Iowa, you can imagine that. That's not how it works anymore. Now, everything is defined by an equal potential surface. And the definition of that surface is, as you see here, 62,636,856.0 meters squared per second squared. How do you turn that into a height? That's the magic of physical geodesy. Right? So that's where surveyors are kind of have to think in maybe a kind of a different way. That benchmarks, well, obviously benchmark, NGS isn't going to go out and tear up benchmarks. Lots of other people will tear up the benchmarks. We don't have to worry about NGS doing this stuff. The benchmarks, the physical marks will no longer define the vertical datum. Like right now, You want to get NAVD88? Yes, you can use a geoid model and you can produce a height that says it's NAVD88. But if you really want to be on the datum, you have to go find a physical benchmark that is part of NAVD88 published by NGS. And then you have to validate that it hasn't been disturbed, right? That goes away. The marks are still there, or hopefully will still be there. NGS is still going to publish them. They just will not define. No physical marks, whether it's horizontal or vertical. No physical passive marks will define either the horizontal or the vertical. So that's what it says here in the bottom. Minimal NGS involvement in the reliance on passive marks. Lots of reasons why surveyors want to use passive marks. There's tons of reasons why surveyors want to spend money with Bernstein and put new marks in the ground. Lots of good reasons. PLSS is as good a reason as any. NGS, the key for NGS is to provide a service where if you choose, you can perform those measurements and have NGS publish that data for you. And that's what they're already doing with Opus shared solutions. So what changes for the new datum for you to obtain heights? Really nothing, right? If you're using GNSS now, dual frequency GNSS now, which I'm assuming everybody here is, and you're using Opus, the suite of Opus tools, whichever ones you might be using, if you're using those, you'll still use them in the future. If you're using real-time network or doing RTK or static and processing yourself, you do the same thing. You apply the geoid model just as you will, except that now the geoid model that you will carry around with you, which will be called Geoid 2020, it will be in your data collector. It is the vertical datum. You'll carry the vertical datum with you in your data collector. And as it says, you don't need passive marks, but NGS will help you provide. If you want to put passive marks, you want to leave marks behind, for whatever reason, NGS can help you do that. That's the big commitment they're making. So, and I've already covered this part, so I just said that. About every year, NGS generates a beta tool, a beta geoid model. It's great stuff. I bring it up here, but obviously it won't work on the screen, so that's okay. I want to tell you this. This is what I want you to do. Take some time. Make a little note. X, the letter X, geoid, G-E-O-I-D, 20 altogether, right? Go to the NGS website, in the little search box, type in X Geoid 20. It's a beta tool, so it's not a functional tool yet. Every year, based on the gravity data that's been collected the year before, NGS generates one of these beta tools to allow people to look at how things are going to change. So if you want to know how things are going to change in your backyard, in both the horizontal and the vertical, you go to this X Geoid 20, you type in a latitude and longitude for some random point, wherever it happens to be, and an ellipsoid height, not an orthometric height, an ellipsoid height. Maybe you've got one from some mark that you've surveyed. You put that in, it will generate for you an ITRF coordinate in latitude and longitude. So it's going to show you the horizontal displacement that we're going to see for the new datum. It'll give you the new ellipsoid height, and it will give you the new predicted orthometric height in the new vertical datum, the North American Pacific Geopotential Datum of 2022, NAPGD 2022. That's the official name of the new vertical datum. Right? So you can use this tool, X Geoid 20, to go predict that. And then you can use that tool to go talk to your clients and say, hey, here's how much things are going to move in our backyard. And how is that going to impact you or us or whatever that happens to be. Now, the one downside for this tool right now is that the horizontal component of it works only in latitude and longitude. And I know for a fact that 98% of everybody else out there is working in state plane coordinates. NGS, maybe you know Michael, many of you might know Dr. Michael Dennis. Michael is the one who's in charge of the new state plane coordinates. And it's my understanding that hopefully by the end of this year, he's going to have some kind of tool that will predict, or that will provide the what the new zones are going to look like for all of the states based on the communications that NGS has gotten from the states. So right now, when you look at the positional differences, it's just the value in latitude and longitude of roughly a meter or so, depending upon where you are. Maybe a little bit more larger than that in Alaska. The state plane coordinates are obviously going to be significantly large. So you really don't have that part of it yet to be able to share with your clients. Important part, transformation tools, taking the data we have now and migrating it to the future. Unlike the transition from NAD 27 to NAD 83, I found this out pretty quickly. Very few organizations had any significant amount of NAD 27 or even NGVD 29 height information of any legitimate level. You know, USGS, Corps of Engineers, TVA, a few state agencies, but you know, Caltrans, of course, a few others. But most states didn't have much. The user community didn't have much. That's not the case anymore. Every community in the United States, pretty much every county in the United States is sitting on a mountain of high accuracy data that's been generated by surveyors just like yourselves because of NAD 83 and because of the Geoid models. They're sitting on this huge amount of data, and all this stuff is going to change overnight. And I can pretty much guarantee that all of those GIS managers out there are going to look at this and go, huh? Well, what's this all about? So again, I highlight why I think the professional surveyors really need to be the ones to get their heads around this so that they can stand up and go, yeah, we got you covered. You know, this is what we do. We got you here. So there will be datum transformation tools, and NGS committed to them just like always. The geometric side, the horizontal side, NAD 83 to the new geometric datum, the North American Terrestrial Reference Frame of 2022. That's not exactly done, but it's pretty much done. There's a tool called HTDP, Horizontal Time Dependent Positioning. Mike is familiar with that, I'm sure, up in fact, I remember he mentioned that in his presentation. So he's familiar with that in Alaska. Most surveyors aren't familiar with it because they've never had to deal with things moving very much, but the tool is pretty already there. NGS will base this all on the ITRF 2020, which is not even released yet. It'll probably come out at the end of this year, and NGS will commit to doing that. The vertical side, this is the toughie. This is the real toughie.
We got one.
There is no. I'm sorry.
We got one question from Jocelyn too. Maybe on the topic you're talking about. So.
Yeah, he might be getting ready to cover it. I don't know.
Okay.
You mentioned talking to the clients, but we work as city surveyor, city engineer for a lot of our local communities.
Sure.
Anticipating the need to help them move away from the idea that they need passive monuments, controlling everything. I think that's a bigger task than actually, you know, putting the data out there and helping the surveyors working in our communities do the work. So many of the ordinances state that our projects have to be on a city benchmark system.
Well, and that's fine. If people want to put passive marks in the ground, that's absolutely cool. And NGS will provide ways, just like they do now with Opus Shared Solutions. If you want to go out and make those measurements and submit that to Opus Shared Solutions, any point you want, as long as it's a reasonably well monumented, and by that I mean no PK nails and shiners, you know, but a reasonably well monumented point. If you go occupy it for 4 hours with a dual frequency receiver, and you're using Opus already, you send that data to Opus and you add a couple of digital pictures. It's real simple, and a tiny little description where the thing is. NGS puts it in a database, and they will maintain it forever. And that data, which they have now, they will perform either the adjustment or transformation to it for the new datums as well. So NGS fully understands that passive marks are really important in lots of communities. Just like you said, it might be legislated, you know, so they're willing to help support that. You know?
Right. And I think some of the communities just need to understand that, especially we're in Central California, so subsidence is crazy.
Yeah.
So those elevations are going to change over time.
Yeah, and all of the states now, this didn't used to be the case, but now with NGS's transition to regional advisors, of course, California's always had great geodetic advisors going back geez, 25, 30 years. But you got Dana Kakamis down in San Diego. Dana's a great one, you know, so he can be a direct source of information about what's going on day to day. So I'd highly recommend, if you're not already connected with him, go to the NGS homepage, look for Geodetic Advisors. You'll find his contact info and rattle his cage. He'll be more than happy to help you out. And all the states now have them, so everybody should be in contact with them. I wanted to end on this part about the vertical transformation. That tool does not exist yet, right? And it will be completely different from anything that NGS has ever done before. The accuracy of that tool, how well it will estimate the difference between NAVD88 and NAPGD 2022 will be based entirely on the amount of and distribution of GPS on benchmarks. And you have until the end of this calendar year to do that. January the 1st, 2022, the cutoff for adding new data. So I highly recommend that everybody who's listening to this, if you have a way to do it, to go out, and there's a link down here. In fact, you can just go to the NGS homepage and just do GPS on benchmarks. They've got a nice little tag for it, and they have a nice map. You open it up and they literally tell you, go find this mark if you can, which specific marks. If you can find this specific mark or one near it, it's a great tool. And they're updating it, I think, about every 2 weeks as new data comes in. So you literally have between now and the end of this calendar year to add new data to ensure the integrity of that vertical transformation. The end of this year, it's done. So whatever the value of the accuracy of that transformation is from data by the end of this year, that's how good it's going to be forever. And NGS will not come back and revisit this. So you've got this one shot and time is running out. So please do it yourself. Talk to your friends and neighbors, your surveying buddies, get everybody out there to try and get those GPS on benchmarks. I cannot say this enough. That's the end of mine. I know I've used all my time, but I always end with good coordination begins with good coordinates, and geography without geodesy is a felony. Boy, I'm just so happy to have had an opportunity to be a little part of this gaggle of stuff. Trent's doing a great job with this. Yeah. This is terrific. And you know, I listened to Mike's session last week. It was awesome. So I'm assuming pretty much everything is following in that same mode, and it will just get better and better and better. You know, absolutely. So, Trent, I deeply appreciate the opportunity to have time to babble about this. Obviously I take this stuff very seriously. Absolutely. And I'm very passionate about it. But we're getting one shot at this, so let's not waste it.
Absolutely.
Anyway,
Adrian had a question. Go for it, Adrian.
Oh, yeah.
Yeah, Adrian here. How come it's only going to happen once? They won't reevaluate every so many years? The GPS on benchmark.
That's first of all, that's a huge undertaking to do that. And what's going to happen post new datum? The folks in California, the Jocelyn, young lady in California, she's already mentioned subsidence, right? What's going to happen post the new datum, so post 2025? Now, NGS has not come out with an official definition yet. This is pretty much just information that's been talked about over and over and over again by those of us who are either directly at NGS or I'm hanging out with my NGS buddies, bending elbows. Once the new datum is out, the agency will develop a plan of gravity reobservations. And they will focus on areas that are vertically moving, like Central California, like the Gulf Coast, like Chesapeake Bay, and any number of other areas. And they will refly those areas on a periodic basis. So the agency is taking this issue of subsidence very, very, very important. And what will happen, just as the surveyors in California see now, everything will be based on an epoch. So if we go back and if you go back and you reobserve an NAVD88 benchmark in 15 years, first of all, how do you know anything? How do you know that mark may or may not have moved in the 15 years since now? That's going to be a big issue. And how much of this data is going to come in? We talked about it a lot, and several of us really pushed for having, other ways to do this. But the reality is, and I hate to say it, very few communities so far have really stepped up and done the job that's necessary. So the agency's pretty much convinced that once this is done, there'll be just a tiny amount of new data that would come in. And it's not worth going through the huge effort that it requires to do a national transformation tool ever again. These are a big deal. These are huge computational efforts. and so that's why NGS will do the one shot. That's it. One interesting part, and I know we're running time here. I was talking with one of the people that's in charge of the gravity program, and this is purely water talk, water cooler talk, bending elbows at the pub talk. But they're excited about the potential of ultimately being able to put one of these airborne gravimeters, one of these gravity meters, which now are pretty big boxes, to be able to put one on basically what amounts to a drone and just put it up and let it fly, as opposed to putting it in an aircraft, and just let that puppy fly. And they could probably refly the entire country in 6 weeks or something like that. I mean, I don't know. There's coming up with all kinds of things that the future will look like. And we all see how drone technology has already changed what we do as surveyors. We can just take that to the next step, which it will occur. The issue is not if it'll occur, when it will occur. It will. So these are parts of the, when Mike gave his presentation 2 weeks ago, and he really emphasized these times of uncertainty in transitions, in our industrial life. This is exactly what's going on right now. I thank him for his comments about that, because that's where we are. And we'll look back on this in 15 or 20 years, at least those of us who are still around, and go, well, I remember the old days when it looked like that, and the tools that we have, the tools that everybody's using now are going to be sitting on that table right next to the K&E transits, and the dumpy levels, going, yeah, I used one of those guys. Remember that? You actually had to input stuff, you had to have a finger, That's remember, if anything comes up to you, you got a question or comment, my phone number was on the presentation. My email is just base9geodesy@gmail, or you can Google me you can find me on on LinkedIn and on that kind of stuff. I got a website, so just if you want to look for me, just go do that. And again, whether it's tomorrow or next month or next year, don't hesitate. I'll be happy to make something up.
That's awesome. Thanks, Dave.
Otherwise, thank you so much. Peace. And it's almost St. Paddy's Day, a holy day of obligation. And so sláinte, everybody.
I love it. Did anybody have any more specific questions for Dave? I'll throw it out there that my very first concert at 14 years old was the Grateful Dead.
Where'd you see him?
Sam Boyd Stadium here in Las Vegas.
Well, yeah.
Zach's got one more. Go for it, Zach.
Oh, yeah, Zach.
Yeah, so you're saying about these benchmarks. How would we go about getting involved in like a subsidence monitoring program? Well, kind of individually.
The best thing to do, and this goes on right now, if you live in an area that's undergoing some level of subsidence, talk to state and local officials. So you might have the DOT, maybe it's county, and talk to them if they're aware of this or they're involved in it. I've seen surveyors do this. We've seen a lot of this here in Maryland and Virginia. They're involved in it because Chesapeake Bay is subsiding a little bit. And so the surveyors are going out, and what they're currently doing is they're observing that GPS on benchmarks. So they're trying to work with those communities to say, okay, we're going to go out here and we're going to re-observe those on a periodic basis every year. Or if the subsidence or uplift, if you're in the northern part of the country, it could be uplift. Maybe it's every 6 months or every year. And you can sit there for, like an hour, that's an hour's worth of observations, and then submit that to Open Shared Solutions, and all of that data gets collected together. So that's one way in which you can do it. If you think there's subsidence going on and there's nobody working on it in your area, that becomes a bigger problem. Now you got to get local governments involved and let people know what you think is happening, because it's a big undertaking.
Right. We have to tie to reference monument, the title reference monument. We're in Florida.
Oh, you're working in the title area?
Yes, we continue.
Okay.
We have to tie to reference monuments set, and sometimes I wonder about them.
Oh, you should.
Some are very, very structurally sound, and some are kind of, it's 3 feet deep in the sand. Like, I know sand dunes move.
Yeah.
So
no, that's a good one. Yeah, especially if you're working in the tidal area. Now, I didn't mention this, but if NGS is coming up with a new geodetic vertical datum in 2020-25, the federal agency that's responsible for the tidal benchmarks, the tide stations, the Center for Operational Oceanographic Products and Services, part of NOAA, basically in the building. Well, actually, they're moving into the same office with NGS. They will be releasing a new tidal datum epoch in 2025 as well. So you're working in the tidal area. You need to be aware of that. It means all of those tide stations are going to change by some amount in 2025 as well.
And that's something I could maybe help contribute to now.
Yeah, actually, and that's an area. I tell you what, if you do this, if you would send me an email, and I will then send you back a contact person at co-ops, and rather than having to go through this on here, I can send you the guy at co-ops that's going to be in charge of this thing, and then he can help you figure out what it is you can do in your community to deal with that. And again, to understand what's going to happen with that tidal data method for you and your clients.
Right. All right. Well, that sounds great. I appreciate that.
Sure.
Zach,
sure.
I'll put you in. I'll put you and Dave on the same email, Zach.
Okay. Thank you.
Yep, that's right. Trent did that for me and my class. Yep, 2 weeks ago.
Worked out good.
Same deal.